Hello everyone, thanks for stopping by. Today we're going to be talking about Math 120, Section 7.4, and let us start off with some definitions. First, dimensional analysis is the study and process of converting between different units. Dimensional analysis is the study and process of converting between different units. It's how we shift from units to units. For example, maybe you start with something in feet, but you want to know how many miles it is. Or you start with something in kilometers and you want to know how many miles it is. We'll see a few different ones throughout this section. So dimensional analysis is the study and process of converting between different units. Unit fractions are fractions that have different units but equal quantities in the top and bottom, in the numerator and denominator, right? In the top and bottom. So unit fractions are fractions that have different units but equal quantities in the top and bottom. And I'm going to put an underline under equal. They're not equal in terms of the number, they're equal in terms of how much they're measuring, the quantity they are measuring. So be careful when I use the word equal here. They are equal in the quantity they are measuring, not necessarily the number. And let's look at some common units that are the same. 1 foot is 12 inches. 1 yard is 3 feet. 1 mile is 5,280 feet. 1 pound is 16 ounces. 1 ton is 2,000 pounds. 1 cup is 8 fluid ounces. 1 pint is 2 cups. A quart is 2 pints. A gallon is 4 quarts. A minute is 60 seconds. An hour is 60 minutes. A day is 24 hours. And a year is 365 days, except on leap years, right? We usually just use 365 for sake of ease, because it gets a little messy if you try and factor in leap years in general. Now, these unit equations help us to create unit fractions. Let's write some unit fractions. The first one is 1 foot over 12 inches. 1 foot and 12 inches measure the same amount, right? That is the same length. This fraction is equal to 1. This fraction is a unit fraction. The top and bottom are measuring the same distance, but they're using different units. We could also have, or maybe, let's say, we have 1 quart over 2 pints. 1 quart over 2 pints. Or maybe you want the larger value in the top. That can happen sometimes. Maybe we have 5,280 feet over 1 mile. That is another unit fraction. Notice I'm using these equations. The values I know are equal to one another create my unit fraction. 1 foot was 12 inches. 1 quart was 2 pints. 5,280 feet was 1 mile. These are unit fractions. So we have this concept of unit fractions. Now, let's look at how we convert. The way we convert is we're going to use these unit fractions. I'm going to refer back to this table so we can see where the fractions are coming from. So let's look first. We want to convert inches to feet. Well, the first thing I always do is write 30 inches, and I'm going to put it over 1. Because I'm going to use a unit fraction here. I'm going to multiply this by another fraction. Now, I started with inches, right? And I want to get things in terms of feet. Let's see here. Is there any unit fraction that relates inches to feet? There is, right? 1 foot is 12 inches. That relates inches to feet. Now, I need to be careful. Inches is in the top originally, so I'm going to put inches in the bottom here. I need to cancel inches, no matter what. And then I'm going to put feet in the top. So I choose the location of my units based on what I'm trying to cancel. If I'm trying to cancel inches in the top, I got to put inches in the bottom. Now, 1 foot is 12 inches, so I'll put 1 foot and 12 inches, right? I need to make sure I respect the values. And now, notice inches will cancel, because inches in both the top and the bottom of my fractions, right? I'm canceling out the unit inches to leave myself with the unit feet. Now, I just need to multiply these fractions and reduce. 30 times 1 gives me 30. 1 times 12 gives me 12, and the units left were feet. And then if I want to divide this out, let's see, 30 divided by 12 is 2.5. So I get 2.5 feet for my answer. Remember, when dealing with real-world measurements, we typically convert things into decimals to get a better understanding of the values. Let's take a look at the next one. It says convert 792 feet to miles. So I'm going to write the unit I have, 792 feet, over 1. I need to convert it. And then the first thing I'm going to do is I know I need to cancel out the feet. Now, my goal is to get to miles. The first thing I should see is there anything that relates feet to miles directly? And there is, right? I can relate feet to miles directly. So I'm going to put miles, MI, up top. And now the unit fraction will be 1 mile is 5,280 feet. 1 mile is 5,280 feet. Now, the reason I put feet in the bottom was because it'll cancel, and I'm left with miles now, right? So, in the top I get 792 over, let's see, 5,280. And I have miles. Now I'm going to divide this out and see what I get. 792 divided by 5,280 gives me 0.15. 0.15 miles. So 792 feet is equal to 0.15 miles. Notice we used the unit fraction. Now let's see a slightly different example. 55 miles per hour. Be careful of the word per. This tells me that it's 55 miles per 1 hour. 55 miles per hour, and I want to convert it to feet per second. So I want feet in the top and seconds in the bottom. This is my overall goal. I'm trying to get feet in the top and seconds in the bottom. Well, I have miles and hours originally, right? The first thing I'm going to look for is I want to get rid of the miles. So the first thing I'm going to do is put an equation with miles in the bottom, and I'm going to put another value in the top. Well, I'm trying to get rid of miles, and I'm trying to convert it to feet, right? I want feet instead of miles. Well, lucky for me, feet and miles relate directly. So I'll put feet in the top. And then remember the ratio is 1 to 5,280. So it's 5,280 feet over 1 miles. Notice it's flipped from the last one because you always need to make sure you're putting the unit you're trying to cancel in the bottom. But I now have feet in the top, right? But I'm trying to get seconds in the bottom. So I need to get rid of this hours. The hours is in the bottom originally. So I'm going to put hours in the top. I'm going to put hours in the top because I want to cancel an hours in the bottom. Now, I'm trying to relate hours to seconds. In my chart, hours relate to minutes. There's no hours to seconds, and hours relate to days. Now, will it be more useful to turn hours to minutes or hours to days? Well, let's see. If I turn hours to minutes, I can turn minutes to seconds, right? If I turn hours to days, let's see, days, that doesn't help me, right? Days to years, that's not the right direction. So I want to go from hours to minutes first. So I'm going to put minutes in the bottom. Now, 1 hour is 60 minutes. So notice now I have canceled hours in the top and bottom, right? I had hours in both the top and bottom. Now I'm left with feet in the top and minutes in the bottom. I'm getting closer. I need seconds in the bottom, though. If I don't want minutes, I need to cancel out the minutes. And let's see, we already said we can relate minutes to seconds, right? So I'll put seconds in the bottom. And we know that 1 minute is 60 seconds, right? And that will cancel my minutes, right? Because I have minutes in the top and bottom. Now I am left with feet per second. So now what I need to do is I need to multiply in the top. 55 times 5280 times 1 in the top. So in the top, I'm going to have 55 times 5280 times 1, right? These ones don't really matter, though. And I'm going to get 290400 in the top. Over, let's see, I get 1 times 60 times 60 in the bottom. Well, 1 times 60, so that's just 60 times 60, right? 60 times 60 gives me 3,600. And remember, this is feet over seconds. So now I am going to reduce this by dividing it. 290400 divided by 3600 gives me 80.67 if we round to 2 decimal places. 80.67. And we can use the phrase FPS for feet per second if we want. Or you could write feet over seconds. Or you could write out the words feet per second. There's a lot of different ways to write feet per second, right? FPS is something we commonly see, though. That is a common unit for feet per second. You also could have written 80.67 feet per second, right? You could have written the unit as a fraction. Once you've divided out, you can write the unit as a fraction, feet per second, just like miles over hours, right? Miles per hour, feet per second. But notice, we used multiple unit fractions here, but our goal was to get specific units. We wanted feet per second, so we turned miles to feet and hours to seconds. These unit fractions I like to think of as the bridges that connect us from one unit to the other. We took the feet by miles bridge, the hours by minutes bridge, and the minutes by seconds bridge to go from miles per hour to feet per second. We create these unit fractions to convert our values. Now let's look at another example. If you're given any conversion, $1 is equal to 1.32 Canadian dollars. That is a conversion rate. That is a equation between units, right? Convert $45 to Canadian dollars. All right, well, I start with $45 over 1, right? There was no unit in the bottom. And then I got to get rid of, well, let's see. In my unit fraction, I want to cancel out US dollars in the top, so I'll put it in the bottom, which means I put Canadian dollars in the top. And I use the relationship I was given. $1 is 1.32 Canadian dollars. Well, US dollars will cancel, right? And I just get 1 in the bottom, so I don't even need to worry about the denominator, right? There's nothing going on in the denominator. 1 times 1 is 1. 45 times 1.32 gives me 59.4. So I get 59 point, and we can write 40 because it's money, Canadian dollars. For my answer. So, you can actually convert any units as long as you have the ratio between the two values. Once you know the given conversion rate between any two units, you can always convert them. That is the power of these unit fractions. They always work in the same way. Let's do one last example. we have 2.5 gallons, which once again has no unit in the bottom, and we want to get to pints. We want to convert it to pints. Now notice gallons relate to quarts. So let's see, I want to cancel out gallons. Right? But they only relate to quarts. I can only relate quarts to gallons because 1 gallon is 4 quarts. So that right there will cancel out the gallons for me, right? But I'm not done. I wanted pints, not quarts. Well, that means I'm going to have to cancel out the quarts. Now, can I go from quarts to pints? Do quarts relate to pints? They do. So this will be the last fraction I need because quarts relate to pints. So I can put pints up top. Quarts to pints. Let's see, 1 quart is 2 pints, right? So 2 pints, 1 quart. And then I can say equals. And let's see, we can cancel quarts, right? We're left with pints. Once again, the bottom, 1 times 1 times 1. There's nothing going on in the bottom. So I just have to multiply the top. 2.5 times 4 is 10, times 2 is 20 pints. So 2.5 gallons is 20 pints. And that should make sense if you know how big a pint and a gallon is. Think about a gallon of milk and a pint of Ben & Jerry's ice cream. 20 Ben & Jerry's ice creams would be about the same size as 2.5 gallons of milk, right? If you tried to stack them up, right? It makes sense. We understand how gallons and pints are sized. We can picture some things of common size in our head. So you always use the unit fractions to convert. Now, let's get a few more unit fractions into the mix. On this page, we have a whole bunch of conversions for the metric system and the US system. And look, it gives inches to centimeters, feet to centimeters, feet to meters, yards to meters, miles to kilometers. Those are for length. Area. Square inches to square centimeters, square feet to square meters, square yards to square meters, square miles to square kilometers, and acres to hectares. Acres and hectares are just specific measurements we use for land. This is the English measurement, this is the metric measurement. They're used for measuring land size. We say hectares in metric, and we say acres in English. Then for volume, we have teaspoons, milliliters, tablespoons to milliliters, fluid ounces to milliliters, cups to liters, pints to liters, quarts to liters, gallons to liters, cubic feet to cubic meters, and cubic yards to cubic meters, right, for volume. And then for weight, we have an ounce to grams, a pound to kilos, and a ton to a ton with N-E on the end. We call this a short ton, and this a long ton. Be careful between them. Make sure you know the difference between ton and ton. Short ton, long ton. And we can make unit fractions here. Maybe we take 1 foot and 0.305 meters. 0.305 meters. Or maybe we do an area one. We say that 1 inch squared is 6.5 centimeters squared. Or maybe we do a volume. 30 milliliters is 1 fluid ounce. 1 fluid ounce. 30 milliliters is 1 fluid ounce. We can set up unit fractions using these values. Now, let's keep these handy while we look at an example. We have an example. The largest flagpole in the U.S. is in Sheboygan, Wisconsin. The steel pole weighs 345,000 pounds. It's a heavy flag, right? The foundation contains 700 cubic yards of concrete. The flagpole itself is 400 feet tall. The flag has an area of 648 square meters. And finally, it took 1,900 liters of paint to paint the flagpole. And then we have a bunch of questions about this flagpole. So let's read the first one. It says 1. What is the mass of the steel pole in kilograms? So for 1, I need to figure out which measurement is relating to mass. Let's see, I have pounds. Pounds is mass, right? Cubic yards, feet, tall, square meters, liters. Mass is pounds, right? So I want to turn 34500 pounds to kilograms. So that's the conversion I want to look for. I'm trying to convert pounds to kilograms. So in my list here, I'm looking at weight, which is mass, and I want to see if I can relate pounds to kilos. And it does work right away, right? I see I can relate them. All right, well, I'm going to use the unit fraction. 345,000 pounds, which is LBS, right? Pounds is LBS, over 1 times. I want to get kilograms, and I want to cancel pounds. So I need to use this conversion rate. 1 pound is 0.45 kilograms. Let's see, 0.45 kilograms and 1 pound. Well, let's see. What's going to happen here? Well, I'm going to cancel pounds, right? And I'll be left with kilograms. Notice in the bottom, we have 1 times 1, so there's nothing going on in the bottom. We just have kilograms, and we just need to multiply. So let's take our calculator out. 345,000 times 0.45 is, let's see, we get 155,250. So 155,250 kilograms. So it weighs 155,250 kilograms. That is the mass of the steel pole in kilograms. So I had it in pounds, and I converted it to kilograms. Let's look at the second one. What is the volume in cubic meters of the foundation? Let's see. The foundation is currently 700 yards cubed, right? 700 cubic yards, and I want to convert it to meters cubed. Cubic meters, right? Well, first thing I'm going to do is write my given unit. And I'm going to put it over 1, right? There's no fractions here. It's not miles per hour. It's not something per something, right? And I'm going to multiply. Let's see. I want meters cubed. Do yards relate directly to meters in volume? Let's see. Volume. Let's see. Where's some yards? Yards and meters. Ah, yards cubed and meters cubed. They relate directly. Well, that's nifty, because that means I can put yards cubed and meters cubed and use this conversion. 1 yard is 0.76 cubic meters. Well, 1 yard is 0.76 cubic meters. So, once again, I'll cancel my yards cubed, and I have meters cubed, right? Well, 700 times 0.76 is 532. Once again, the denominators have nothing going on, and I'll get meters cubed. So the volume of the foundation is 532 meters cubed, which is the same as the original 700 yards cubed, right? I just converted the units. Now, how many meters tall is the flagpole? Well, how many meters tall is the flagpole? Well, first I got to find how the flagpole was originally measured. It was 400 feet tall. So 400 feet, and I'll convert that to plain old meters, right? 400 feet to meters. Well, I'm going to write 400 feet over 1, because that's what I need to convert. And then let's see. I'm looking for feet to meters. Let's see, that's a length, right? Let's see, feet to meters. Oh, I can relate feet directly to meters, can I? That's good, because I want to cancel feet and leave myself with meters. So let's see, what's it say? 1 foot is 0.305 meters. So 1 foot is 0.305 meters. We've seen this a few times now, but we're going to cancel feet, right? Because that's why we put feet in the bottom. Let's see, we got ones in the bottom, so I just need to figure out the top. Let's see, 400 times 0.305 is going to give me 122, right? 400 times 0.305 gives me 122. 122 meters, right? I converted to meters. So how many meters tall is the flagpole? 122 meters, which is 400 feet. Now, what is the square footage of the flag? So square footage is a measure of area. So I need to think about what the flag's original area was. That was 648 square meters. So for number 4, I want to take 648 meters squared and convert it to feet squared. Well, can I convert meters squared to feet squared? Ah, right here. Feet squared and meters squared. Good. So I'll write 648 meters squared over 1 times, let's see, I'm trying to cancel meters squared and get to feet squared, right? Well, let's see. 1 square foot is 0.09 meters squared. So 1 square foot is 0.09 meters squared. So notice the meters squared will cancel. I'll cancel my meters, right? And I'm left with, let's see, in the top, I get 648, and in the bottom, I get 0.09, and the units are now feet squared. So now I need to divide. So I'll take my calculator, 648 divided by 0.09 gives me 7,200 feet squared. 7,200 square feet. So for number 4, the square footage of the flag is 7,200. It was originally meters squared, now it's in feet squared. The last one, it says, what is the volume in gallons of the paint used to paint the flagpole? Well, the original measurement for the paint was liters. 1,900 liters, and I want to convert that to gallons, right? Well, once again, I'm going to check if I can I go liters to gallons? Ah, yes, gallons and liters are on my list, right? Gallons and liters are on my list, so that's going to be nice for me. I have 1,900 liters over 1 times, and I want to cancel liters and leave myself with gallons, right? Cancel liters and get gallons. Let's see. In volume, let's see. We had 1 gallon is 3.8 liters. 1 gallon is 3.8 liters. So, we have 1,900 times 1 in the top over 3.8 and 1 make 3.8, right? And we should probably write that we're canceling the liters just for completion's sake. And the new units are gallons. And then we can divide to simplify. 1,900 divided by 3.8 gives me 500 gallons. So it took 500 gallons of paint to paint the flagpole. And so this question gave us 5 different units that described the same object. It was a flagpole. It described how much the flagpole weighed, how large the base of the flagpole was, the foundation, how tall the flagpole was, the area of the flag itself, and how much paint it took to paint it. And we converted all of them into a different unit than what was given. Notice some of the units ended in metric, and some of them ended in English units, right? In the US system of units, right? So we can go vice versa, right? We can start with metric and change to the US system, or we can start with the US system and change back into metric. All we need to do is know these values here. So these will be good to keep on hand. You'll want to keep these tables, these comparison values. Think of these like formula sheets, right? You'll want to keep these values nearby. And that brings us to the end of section 7.4. Thank you for stopping by, and I will see you next time.